Did you know that .NET has three programming languages? There is C Sharp, there is F Sharp, and there is VB.NET. Those are three programming languages. Most of the time when you hear people talking about .NET, they are usually referring to C Sharp. And that's because C Sharp is the most popular .NET programming language. .NET itself is not a programming language, but it is an ecosystem. It's made of the people that contribute to the ecosystem, the different tools that are created for the ecosystem, and also those three programming languages that I listed earlier, meaning C Sharp, F Sharp, and VB.NET. In this video, I will be demonstrating how you can use those three programming languages in the same solution. So we will be using C Sharp, F Sharp, and VB.NET in the same solution. Hello everyone, my name is Arthur Kamsu, and let me tell you a little bit about what we are trying to achieve. We want a console app that will allow us to see the new salary of our employees if we were to give them a raise. So the raise is going to be in the form of a percentage. Let's say I have an employee that salary is $100,000 a year, and I want to give them a raise of 10%. The console app should be able to display the new salary, which will be $110,000 a year. And we will be doing that using C Sharp, F Sharp, and VB.NET in the same solution. Without further ado, let me show you what I have here. I just have an empty solution right now, and I'm going to start by adding a new project to it. So I'm going to go to add a new project. We are going to start with a VB.NET project. So I will be calling it Visual Basic.NET. Let's do, .NET. And let me choose the location and go to next. .NET 8, okay, you can see that it comes with a class by default. So I'm going to rename this class to employee. It's going to be our employee class. Yes, I want to change that. I'm going to start by implementing the property here. The way you do that in .NET is you do public property. Let's start with ID, and then as integer, and then I want another public this property. Oops. Let's do last name as string. Okay. And next one, we want to do public property first name, and we want to do that as a string as well. And we want another one that's gonna be public property middle name. Yep. And that's gonna be a string. All right, so we have this. We can add the salary, public property. Let's do salary. Let's do as a decimal. Yeah. Let's do a full name as well, but this one is going to be a read-only property. So I will do public read-only property full name and I'm going to do that as a string as well. And this is going to be different in the implementation because I would do a get and set in this case. So let me add my n property here. Okay, property. All right, so this closes this, but I do have to implement that. So I'm going to start with a get, and I'm going to do since it's just a read-only property, the only thing we are going to implement here is the get and the end get. So I'm talking about this. Okay, so let's do that. So we will do something really simple. Okay, let's do if our middle name is null, it's empty, it's nil or empty, and that's the middle name. Oopsie, yeah, VB.net, and then so what do we want to do here? We want to return, if the middle name is empty, we just want to return the first name. Let's start with the last name. Okay. Oh no, the first name. Let's do the first name. That's gonna be this first name. First name. And we want to add the last name to it. All right, so we have our last name and the first name. That's what the full name is going to be if the middle name is empty. I'm going to add an else statement here. I'm just going to copy this. If the middle name is not empty or is not null, then we want to return that middle name as well. So that's going to be first name, middle name, and last name. All right, I think this is good enough for our employee class. And by default, the namespace will be the name of the project. So I don't really need to add that here. All right, this is good enough. Let's create, let's say the Visual Basic project is actually our repository, right? Let's create a repository class here. So I'm going to do add, I can do new item, yeah. Let me call it employee repository, something like this. And I'm just going to return some data here, not really going to the database or anything like that. So I'm just gonna go ahead and try to generate some data, and hopefully, so that's going to be a single function that will return a list of employees. So we have our function now. Can walk you through it. As you can see here, I have a shared function. This is a static function, and you can see that it returns a list of employee. This is the list of employee that it's returning. This is the first employee with a salary of 100,000. You have the second one with a $50,000 salary. So the one last thing I can do here is to add the namespace to, I don't really need to add the namespace, but just adding it here to clarify the the namespace. So let's do the namespace will be Visual Basic .NET. Okay, that's what we did. And my class has to be in the namespace. So I'm going to put it right here. All right, we're good here. And additionally, I can also add the namespace to our employee class to make sure that they are technically in the same namespace, even if I don't add it here. But just for the sake of clarification, I will be adding the namespace here as well. All right, so we have everything ready. I think it looks good. We have our employee, we have the salary, we have the full name, and we have our repository that just returns the list of employee. All right, at this point, everything's good. So I'm gonna go ahead and commit that. I can say at the VB Visual Basic projects, and I can additionally maybe a little bit specific. To be a little bit specific, I can say add the employee class and add the employee repository. All right, I think that's good enough, and I can commit this and push everything. All right, I think we're good with our VB.NET project. This will be treated as our repository. So now it's time to start our F# project. All right, so let's go ahead and create our F# project. So I'm going to go to add new project, and I'm going to choose F#, and it's going to be a class library. I will choose where to save the project, and let's call this F#.NET. And I think we're good here. Next, and we can create. Okay, you can see that it comes with a library by default. So I'm going to create a type. We don't technically need it, but I'll create a type that I will call employee with target salary. Okay, so this type will be returned whenever we are calling the function that we'll be implementing shortly. All right, let me clarify the namespace. Let's put that here, namespace. All right, let me add this a little bit so that you guys can see. Okay, so the type here will take in an employee ID, and that's going to be of a type integer. It will also take the current salary. So current salary, which is going to be of a type decimal, and it's also going to take in a target salary, which is decimal as well. And remember that this type is the one we will be returning whenever our function is called. We have not implemented the function yet, but we will do that shortly. All right, so we are creating the members right now. So let's do member. This let's do employee ID, and then we are going to say it's of type integer, and we are assigning the employee ID that we're passing in. The other member is going to be the current salary, and it's going to be of type decimal, and that's going to be the current salary that comes in, and the last member will be the target salary. That's going to be of type decimal, and that's going to be coming from the target salary. That we have our type ready. I know there's a lot to learn here because the syntax are just different. Here in F#, this is one of the ways how you can create a type, but in VB.NET you saw that we were doing something completely different. So technically these are our properties here, and this is our constructor, and that will be a default constructor or a primary constructor, something like that. So let's implement a toString function that will be this, oops, and let's call it toString, and that's going to be a function, and we will just print something. Let's do, yeah, print is enough, and we can do this key. So we'll say employee ID, and here you will use ampersand, the percentage sign instead. You do something like this for printing an integer or a decimal, I think. So I would do comma, and then we do current salary. Okay, and we can do another %d and target salary, do another %d. Okay, and then we have to pass in those values. So it's going to be this employee ID, this current salary, and this target salary. All right, so our toString function is implemented, and I can quickly explain this. The toString function just prints something that could be on the console app, and it takes in these three parameters. Let me move this a little bit, and it will just replace this with the value of employee ID, replace this with the value of current salary, and replace that last one with the value of target salary. This is how you define a type or a class, but in C# you mostly call it a type. Oh no, not in C#. In F# you mostly, it's kind of confusing to work with all these languages. All right, so in F# you mostly call it a type, and this is how you define it. All right, I think the type is ready. Now let's go to, we are not going to call this Like we can call this our, let me rename it to race manager, something like that. All right, our race manager, and we are going to keep it as a module. In F#, a module groups a list of function. So we're keeping it as a module, but we are going to rename it to our race, what did we call it? Race manager. Okay, race manager. All right. So we have our module called race manager, and we have, this is a function. So we are going to change this function to add race. It would take in a list of tuples, each tuple made of an employee ID with his current salary, and then it will return a list of employee with target salary. So, oh, I did miss something here. For integers, you have to do %D, but for decimal, it's M, because we're dealing with decimals. Okay, I think that's good now. Let me save that. All right, let's go back to the race manager. Our add race function, as I was saying, is going to take a list of tuples. And a tuple is, in this case, going to be an employee ID with his current salary. And then it will return a list of employee with target salary. I think maybe we can rename this to employee ID with target salary. That would be better naming, but it's okay. Don't really have to. But I'm going to rename it to employee ID with target salary. All right, cool. Race manager, I'm going to spare you guys the implementation of this. I'm just going to explain it, and let me see if I have that implementation here already. So I'm just going to copy that from one of sources that I have. Let's see. All right, so this is what we have, and here I'm going to call this employee ID with target salary. All right, it's happy now. So this is our implementation, and let me do a little bit of explanation here. So our function is called add race, and it takes in basically in F#, you have tuples that are references and some that are not. In this case, we are trying to pass in a struct instead, because we want some compatibility with C#, right? If we were to remove this struct, then the tuple that we are declaring here will not be compatible with C#. So basically what we're doing here is, okay, we want our employee ID with initial salary to be a list of struct. The first member of the struct is an integer, and the second member, it's a decimal. For those who are familiar with F# will easily understand this. And here we're passing in the percentage of the raise. So if we want to raise the salary by 10%, then we will pass 10 in here. And in employee ID with initial salary, we will give our employee IDs with their initial salary in a form of tuples. In C#, it will be tuples, but when it gets to F#, it becomes a struct. That's to manage the compatibility between F# and C#. All right, you can see here we're just checking if that percentage is greater than 100 or it's less than 1. Then we throw an exception, an invalid exception. In this case, let me add a message here. Let's say invalid percentage, right? We can have something like this, or maybe we can be a little bit more explicit and say must be between 1 and 100. Well, that's good enough. So what we're doing here next is just to take in that list of tuples, and we're basically doing a map on that list. We're transforming that list. That would be this will be the equivalent of select in link. So we are mapping that list, and we are taking each struct and we are returning an employee ID with a target salary, and we are passing in the employee ID, the initial salary, and then we are passing the salary with the raise. So this is the initial salary, and this part is calculating the raise. It's pretty straightforward. So here you see initial salary times percentage divided by 100. Here I'm just casting the percentage because it comes in as an integer and I have to cast it to decimal. So I think this is good enough for our S# project. So the race manager is okay. We have employee with employee ID with type. Let's change this file to match the type. Okay, so I changed that, and here it is. You can see employee. This is our structure, our solution structure for now. So we have our F# project ready. We have our VB.NET project ready. I think we are ready to go to the next phase, which is creating our C# project. And the C# project will be, we'll call the race manager, and it will pass in the list of tuple made of employee ID and their current salary, and it will receive back that same employee IDs with the initial salary and the computed initial salary plus raise. All right, so that's good. Let's go to our C# project now. To create our C# project, I'm going to do the same thing. I go to solution, right click, new project, and in this case I'm going to choose C# class library, and I'm going to choose the location, and let's call this C#.NET. Okay, and next, and create. All right, comes with a class. Okay, also, so let's create a class called table record. Table record. Yeah, that's good. Oops, yeah. want to change that. So we call it table record. Table record. Yep, that's good. All right. So let's do properties. So in the table record, we want to get the ID. We can have it as an integer. This is C#, so we start declaring the type first. So it's going to be public employee ID. Yep, employee ID. We can do the normal get set and all right, let's see what you got. Well, it doesn't want to help me no more. I don't want description. All right. So we had, let's do the full name. We can say full name. That's going to be, let's fix this. We don't need to call it employee ID. So let's do ID, full name. We can do current salary. Current salary. That's going to be decimal. And can just copy this. And target salary. So this type is going to be useful in displaying data. So it's not really for doing anything else than displaying data. Yeah, you're complaining. All right, makes sense. But I don't really care about that for now. All right, let's just save this. And let's create a helper function that will take in some data and will return a string. So let's call it display helper. We can have a static, can be just a, have it as public as well. Yeah, we can make it a static class. It's okay. Another public static string display helper, display table. Okay, so it would take in some, let's say list stuff or collection's fine. So we want a collection of table records. And I can call it table records. And what it's going to do is just going to go through the table record and create a string version of a table that would be displayed on the console. So I'm going to spare you the implementation of that. I can just do this. There you go. And we have a string builder here. We have a full name. These are going to be the column. Full name, the ID, the employee ID, the current salary, and the target salary. And oh yeah, maybe we want to keep this as well. The total of the current salaries and the total of the target salaries. So this will just return, yeah. I think this is good enough. I can do All right, table record, we have ID instead of employee ID. We have current salary. So what we're doing here is we're just using a string builder to create a string that will be displayed on the console. And we're trying to make it look like a table. So I think this is self-explanatory. I don't really need to explain anything here. So we have, I can maybe say total of current salary, right? Salaries, all right. And I can say total of targets salaries here. So this is just going to display each employee with his full name, his employee ID, his current salary, and then his target salary after the raise. And I will have a kind of like a total of current salaries where I know exactly how much we are paying all our employees right now, and how much we'll be paying all the employees after the raise. Yeah, I think this is pretty good. It's good enough. All right. Oops. How did you get here? All right. I think we're good with the C# project. I think we have all the pieces together. We have our table records. We have this guy is still complaining here. I can, to get that go away, I can just initialize it to string.empty. But this is basically just complaining because when you create a C# class without a constructor, it will by default create an empty constructor for you. And since that constructor, that default constructor, is the only one in the class, it has to initialize the properties. So at the exit of that constructor, full name should be initialized. These ones are not complaining because by default they are 0. But a string by default, you can set it to null or you can set it to string.empty. It depends. Actually, it shouldn't be null at the exit of that constructor because it's not nullable here. So yeah, I think we're good. We have all the pieces together. Now we can create one more project. Actually, we are going to do that, and we can choose whatever language we want to implement that project is in, because it will basically just call each of our projects that we have already created. So I'm going to create one more. It's going to be a console app this time. So it's going to be in, let's do C#. C# is my favorite. All right, next up, I choose the class library, console app. Yeah, next. And I'm going to call it race manager. That's better. Race manager. All right. So I'm going to choose the location. And next, .NET 8 is fine. Yeah, we want to do top level statement. AOT, we don't really care right now, it's fine. All right, so we have our console app right now, and all we have to do right now is to add reference to, I can do that here, dependencies. Oops, there's no project yet because I've not added any. All right, so I will do add, where's that at? project reference. So I'm going to select all the previous project that we created. All right, so now I have reference to all our projects. Oh yeah, it does have. Okay, so we are good to go. We just have to first get the list of employee, and that is in the VB.NET project. So, and that was, if you remember, we had it in employee repository. So I'm going to do this employee repository list. Employee. Oh, I can just say employees. That would be good. And I can do this get employee. You can see that the integration or the compatibility between VB.NET and C# is just great, because I don't need anything else. I can just call this. This is actually coming from VB.NET. The implementation of this is VB.NET, and I can call it in C#. I'm right here in the C# code, and so I have the list of employee. What I want to do now is to call the F#, project, and I want to call the race manager in the F#, and this is what I'm talking about. This @race function. Right, that's what I want to do. But I have to pass in a list, a C#, an F# list, because there's a difference between an F# list and a C# list. That's where F# is not really, I mean, it's compatible with C#, but there are just some areas where you still have to do some additional processing before it can be compatible. In this case, you will see that I will have to transform the list that I have, which is a normal list. You can see here, it's a C# list. I have to transform it from a C# list to an F# list in order to make this call here. No, not here. In order to call this function. And the way I would do that is I have to get something. I just want to spare you guys that. And the time of implementing this. So here I have to convert this regular list to an F# list. There's a dedicated class for that. So here, this is what I'm doing. I can maybe bring this down a little bit. All right, so that you can see. Or maybe I can just do this. That will be fine. All right. Okay, so what I'm doing here is I'm using a list module. This is coming from F#. And you can see I have the import here, the import statement, but here we are in C#, remember. So this is just for compatibility sake. We need this class to transform our regular list. With VB.NET we don't need that, but with F# we need to transform our regular list to an F# list, and this is how you do it. Use the list module, you use this function offsec, and it takes in the regular list. But in this case, I don't want all the properties that are in employee, right? I just want the employee ID and the salary. That's why I'm doing a select right now. And I'm choosing the ID and the salary, and I'm putting it in a tuple. So this will return an enumerable of tuple of ID and salary, and that enumerable will be transformed in a list, in an F# list. And when I have an F# list, now I can go ahead and call our race manager. And the way I do that is I will do this race manager. Oh, I hope there's no conflict of naming race manager. Let's see. Oops. Let's see, race manager. Race manager. The address. All right, let's see if it will recognize it. Nope, doesn't. Okay, let's do using F#. Oops. Sharp.net. All right, doesn't know it, and I do understand why. And that's again the compatibility issue that we have with F#. So I'm going to build this because I think F# you will need to build it, and the DLL that comes out of that build will be the one, even though we did add the reference to the project, unless you build that project, you will not be able to access it in C#. So that was the problem. And now we can we built the project, and then we can access that function that we had. All right, so this is our add race function. It takes in an F# list, and I already have an F# list. I can call this employees as F#. Oh, as F# list. I think that's a good naming. Not really great at naming things, but I think this is great. All right, so we pass in our list, and what's the percentage? Let's do 10%. All right, we want to give a raise to everyone, 10% of their initial salary, and that's going to give us a list of table records, if I'm not mistaken. Okay, employee with race. I think this is too big now, so let me reduce that. All right, so employee with race is giving us oh no, it's giving us a list of employee with target salary, not employee with not table record. All right, now we have our employee with target salary. Next thing to do would be to transform that into table record, and then call our C#.net project, specifically our display helper, to display that for us. So the way I'm going to do that is I'm going to do these table records, and now we do employee with race. I can do select, employee. Okay, trying to help me. All right, I want to do new table record. Yep, knows it. So I will do this. Employee with raise. Employee with raise. Target salary. I think I have something like that. Current salary. Current salary. We can do employee ID. All right, so full name. Carl. Did I get a full name? Let's see. Oh no, I don't have full name here. All right, so if I don't have a full name here, then I will have to join. I will have to join this with the employee to get the full name. So the way I would do that will be, all right, I have the employee with raise. So yeah, I can use this again and get rid of this because I will have to join. So that's gonna be table record and employee with raise. Employee with raise, and I will join that with my employee, and then I will join that on what? I will join that on employee. All right, so I want to join that on my employee. Oh no, the first is employee with raise. So I want to do ID. So, and I want to join the other one on, the other one is just simple employee. I'm going to rename this. So we have, because we have employees with raise and we have simple employee. So let's do, here we do employee. Yeah, we can employee with raise. All right, let me name it well so that we know what we're doing. So here we do employee simple. So here we are joining our employee with raise and our employee, and we're joining them on their ID. And now from those employee, so we can do something like the employee with raise dash employee. So what do we want to get from here? We want to get table record, right? And each table record, let's fix this. I like the code is beautiful. All right, so what we have now is that we have yeah, ID is good. Let's see, you're not helping me. Good job. All right, full name is good. Current salary, no. current salary should come from employee with raise. Employee with raise, current salary, and then target salary. There you go. I can also do this here. It doesn't matter. In this case, it will be employee ID. All right, so I have my join statement, right? I'm joining employee and employee with raise, and I'm getting an I enumerable here, but we can call it a list. We can get a list out of it, and we have our list. Now we're going to call our helper function, because the helper function can take a list now. So let me reduce that so that you can see. All right, reduce that again. All right, cool. So we have that. Now let's do table. Let's call this table display equal display helper, and this is from our C# library. If you remember this one, display helper, this is our display helper here. This is the one that this display helper, and you can see that it comes from our C#.net. So that's what we're using, and it takes in a collection of table record. I think a list will go just fine. I can check if I can do to collection there. To collection up, I can't do to collection here. Mutable. Well, I think we can just let it as a list and maybe update it. It's not a big deal, but we can just update this to a list. That's not the point of this tutorial, so we can leave it as a list, but I will not leave it as a list in the production code, because we are not really using any property of list here. We are just iterating. Right? We could also do I enumerable, but it's fine, because we are iterating only once here. So no, let's even do that. I think this should be fine in this context. I enumerable. All right, I think we're good in this context. So if I go back to my program CS, this is just fine. Okay. So now we have our table to display, and we can just do console.writeLine table to display, and we'll be just fine. All right, let's see. I think this is a pretty good stopping point. So let's see. If we go to our repository, we have 1, 2, 3, 4, 5 employee, and if our program is working correctly, we will have 5 employee, and we will have the races. We will see if this normally should display 110,000. This should be 55,000. This should be 10%. 220,000 and so on. So let's try. Let's see what it gives us. Oh, class library. All right, we want to set this project. Where is it? Race manager. We want to set this one as a startup project. So that would be the one. So where is it? All right. As you can see, we have a full name, ID, current salary is going to be 110, which is what we expected. And yeah, I think everything looks good. Just that right now you cannot restart the program unless you run it again. You can do something like a do while or while loop, but that's not the point of this tutorial. So well, you can go ahead and play with it if you want, but I think everything looks good. Let's run that again. Okay, where is our time? Here. So you can see the initial salary here is 100, and the target salary is going to be 110,000. I think this is good enough. I think with this we are showing that we can use C#, F#, and Visual Basic in the same project. The only thing to look out for is the compatibility between F# and the other programming languages. I think VB.NET and C#, they have a great compatibility, and maybe in another video I will show you what I mean by that, because I do think they actually are just the same thing written in a different ways. But we will see that probably in another video. Yeah, I think this is good. So there you go. We have used C#, F#, and VB.NET in the same solution, and this is going to be available on my GitHub account, and feel free to play with it if you want. The one last thing I will maybe talk about before the end of this video will be to see the different file extensions. You will see that in the case of Visual Basic.NET, the file extension is usually VB. In the case of F#, the file extension is FS, and C# is CS, and that goes the same way with the project files. For example, this file here will be an FS proj file, and maybe I can show that really quick if I can go to my sources. And here, if I go to visualbasic.net, then you see that the project file is vbproj. If I go to c#.net, the project file is csproj. If I go to f#.net, then you see that the project file is fsproj. So, but they're ultimately in this same solution that I have right here. And there you go. That's how you can use C#, F#, and VB.NET in the same video. Oh, in the same solution.